Welcome to Computer Structure and Switching Theory. The first lesson is about numeral system. Let's start from something that we already know. A number is represented by a series of digits, and every digit has a certain weight. For example, let's say 327. The last digit, 7, have a weight of 0. The second digit, 2, have a weight of 1. The third digit, 3, have a weight of 2. As you can see, the weight of a digit is calculated by its position in the number. Now we can apply the same principle for decimal numbers. For example, let's take 3920.43. How can we figure out the weight of each digit in this decimal number? Let's start from what we already know. 0 will take the weight of 0. 2 will take the weight of 1. 9 will take 2. 3 will take 3. Now for the digits after the decimal point, we will do as follows. 4 will take -1, and 3 will take the weight of -2. 327 and 3920.43 are numbers in the base 10 numeral system. This system is also known as the decimal number system. The base 10 numeral system is the system that we use in our day-to-day life. This is the general formula to decompose a number in base 10. D represents the current digit, 10 is the base, I is the weight, and this symbol is the summation symbol. For example, let's look again at 327 and apply the formula. 327 is equal to 7 multiplied by the base 10 to the power of 0 plus 2 multiplied by 10 to the power of the weight, in this case 1, plus 3 multiplied by 10 to the power of the weight 2. This is the digit, this is the base, and this is the weight. Now we can ask the question, is it possible to represent a number in a different base other than 10? Yes, it is possible. Now let's look at the second most used numeral system in the world, the base 2 system or the binary system. It's the same thing. Numbers in electronic system are stored as binary digits. Binary numbers are in base 2 numeral system. Here are some examples of some binary numbers: 0, 1, 2, 3, 4, and 5. Note that in base 2 we can only use 0 and 1. A total of 2 numbers, hence the name binary. It's important to note that 19 could be a base 10 number, but it can't be a base 5 number because the digit 9 does not exist in base 5. A number in base 5 must be built from the digit 0 to 4. But 41 could be a base 10 number and also a base 5 number, because in base 10 we can build numbers from the digit 0 to 9, and in base 5 we can build a number from digits 0 to 4, and this is the case. Usually, to differentiate between 41 in base 5 or 41 in base 10, we write the numbers as follows: 41, and in the last digit below we write the base, in this case 5, or 41 base 10. Now it's important to note that 41 in base 5 does not equal 41 in base 10. Now let's see how we can transform a number in base 5 into a base 10 number. This is the formula for transforming a number in base R to base 10. This is the summation symbol like before. D is for the digit, multiply by the R, the base, to the power of the weight. Let's look at 41 in base 5. Now we can convert 41 in base 5 to base 10 by using this formula. Let's do it. 41 base 5 is equal to the digit 1 multiply by R, the base, in our case it's 5, to the power of the weight of the digit 0 plus 4, the next digit, multiply by R, the base 5, to the power of 1, the weight, and we get 1 plus 20, which equals to 21 in base 10. This means that 41 in base 5 is equal to 21 in base 10. Now we can do this thing for every base. In this case, R is equal to 5. Other important numeral systems are base 8 and base 16. These bases are important because they are a power of 2. 2 to the power of 3 is equal 8, and 2 to the power of 4 is equal 16. Now let's look at this binary number. I added 2 to represent a binary number. Now because 2 to the power of 3 is equal 8, if I separate this binary number to 3 parts, each part containing 3 digits, like this. Of course, I'm gonna start from right to left. We will get the following partition: 1 1 0, 1 0 0, and 1 0 1. Now this number this number in binary, we can convert it into decimal. If we do that, we get 3. In this case, we get 1. Here we get 5. This means that 1 0 1 0 0 1 0 1 1 2 is equal to 5 1 3 in base 8. this is an easy way to go from base 2 to base 8. You just need to do a partition. Every partition contains 3 digits from the binary number, and of course you need to start from right to left. Now if you are missing a number, let's say like this, 1101 001. Now if we're gonna do this partition, of course we need to start from right to left. We get 110 100 and 1. Now in here we can just add zeros to the left, and this binary number will be 3, 1 and 1. This means that 1001 011 in binary is equal to 113 in base 8.